Thank you so much for having me. Welcome to Exit Stage Left, Eradicating Security Theater. My name is Kelly Shortridge. I'm VP of Product Management and Product Strategy at Capsulate, which is a startup based in New York City providing infrastructure monitoring and detection for Linux systems. In my spare time, I also research the intersection of behavioral economics and information security. So let's start with the problem. Infosec often laments that it feels like no one else cares about security of our data or of our systems, can see itself as kind of this misunderstood Nostradamus who is saving the rest of IT from itself. And Infosec certainly can come across like a prima donna here. Infosec isn't exactly known for stating its hesitations calmly or constructively. It tends to be boisterous in its displeasure with developers, operators, and users, can be prone to hyperbole when defending its importance. What I've seen too many in Infosec consistently miss, though, is that developers and operators do want to deliver safe and secure software, but they also know that they're primarily judged on the delivery part, not the security part. Infosec, in a kind of classic Shakespearean tradition, bites its thumb at them in response, then leaps onto the security theater stage instead, to all of our detriments. So, what can we do to remove the drama and the pain from security theater and actually start delivering secure software? This talk will explore one way to start. So in this talk, in Act 1, we'll welcome you to the security theater. In Act 2, there's fisticuffs between security theater and security chaos engineering. And in Act 3, there's redemption through security approval patterns. Let's get started with Act 1, Welcome to the Security Theater. To spoof the classic song, welcome to the security theater, to the magic, to the fun, where snake oil tools and roadblocks grow and blaming rings fortissimo. What do we mean by security theater, though? Similarly to the term's origin on the physical security side, security theater involves effort towards producing the perception of improved security. Unfortunately, creating the perception of security is mostly at odds with creating meaningful and valuable security outcomes. The end result is that you produce a lot of drama, histrionic theatrics, loud enough for the whole audience to experience. Security theater is obsessed with the so-called bad apples, referring to the types of humans who do something malicious or careless. Of course, these types of humans are also incredibly rare. The problem is security theater involves policies that apply to everyone because you have to be hyper-vigilant for those bad apples. As Bogner said, there might be someone who can't be trusted. The strategy seems to be preventative control on everybody instead of damage control on those few. This philosophy basically sucks for everyone except for the actors on the security theater stage. In Infosec, this is why we see the Department of No. They say no to all requests by anyone, just in case it's by bad apples. And it fuels the high conflict relationship we so often see between security and engineering. Jez Himpel did some work on risk management theater and noted that any sort of theater is a common encountered control apparatus imposed in a top-down way, which makes life painful for the innocent but can be circumvented by the guilty. So as an example, is the security scanner in place because it's actually resulting in safer software, or because it is a best practice and because Gartner tells you to do so? Are the findings from the tool resulting in meaningful fixes or changes, or is it powering pretty visualizations? It's a common practice of security tools with poor ROI across the board to wreak destruction on software delivery, like railroading product launches or halting deployment. So to continue with our prior example, some AppSec tools take so long to do code checking that they'll inherently interrupt build pipelines. This absolutely makes life more painful for everyone involved and inevitably also hurts business goals. So are these tools also flagging high severity issues that are solidly signal rather than noise? Are they servicing a mix of low severity vulnerabilities that don't even apply to how the code is being used? Human attention is precious, and developers will start to assume that these security tools are just useless with enough consistent noise. This is why, if a security tool is smashing through your delivery pipelines or substantially slowing your ability to deliver software while rarely surfacing real critical issues, it will be perceived as less than useless by your engineers. The goal here, though, really is for a developer or architect on each team to understand things like threat modeling to help build systems more securely by design. Instead, what we see, though, with quite a bit of the whole shifting left thing is that it's catch the OWASP top 10 or whatever our security tools deem is important, but during the build phase rather than the deploy phase. Maybe there's a slight benefit to shifting all that friction earlier, but let's be real, it's pretty minimal, and it's certainly not part of that stated goal of building systems more securely by design. Relatedly, there's the buzzword DevSecOps, which I still think is useless at best, but in an ideal world, DevSecOps is just about similarly unifying accountability and responsibility like we saw with Dev and Ops becoming merged. In the real world, though, DevSecOps says, I'm not a regular security theater, I'm a cool security theater. It's basically a security theater with like a fresh makeover. They're deploying code and image scanners rather than firewalls or antivirus engines, and throwing the word automation around as many places as possible. The problem is it can't be this us versus them mentality, right? If security can't trust engineering teams, that's a culture problem and probably a process problem, but it's not a technology problem. And as we'll discuss in the next section, localizing changes really is the best way to thrive. So if you think of DevOps like a building, security smashes into it like the Kool-Aid man. And why stop at DevSecOps? Why not DevSec test ops? Why not DevSec test DBA ops, right? If we're actually delivering secure software, then it's a seamless part of DevOps processes, and its insertion into the buzzword is totally extraneous. But that's actually the thing. There's an incentive on the security side for it not to be seamless, for security to still be considered distinct but equal. So as I discussed in a recent blog post about the concepts of YOLOSEC and FOMOSEC, FOMOSEC can be thought of any security strategy that's driven by a fear of missing out on all of the related thought patterns. What gains the spotlight with FOMOSEC is escaping the feeling of inadequacy. We're gaining a sense that security is in control and isn't irrelevant, even if that's at the expense of security outcomes. Envy is actually at the heart of FOMOSEC, and for the context of this talk, the target of Infosec's envy is actually software engineers. Dev and ops processes are actually measurable and meaningful goals that are part of obviously meaningful work, allowing them to somewhat easily answer a question like, did you deliver software that customers will buy and use? But Infosec's goals are largely nebulous, and its success is usually abstractly shaped and bittersweet at best. You can see why they're envious. When security wants to cover every last inch of attack surface, when all vulnerabilities are treated like they're mission control and a sort of Pokemon gotta catch 'em all mentality, and when security approvals are demanded on every last bit of code that's shipped, all of this is part of FOMOSEC's melodrama on stage at the security theater. Ironically, though, Infosec's FOMOSEC-driven lust for the idea of being treated equally to Dev and Ops at the big kids business table makes it lose sight of the organizational priorities. And it's so intent on maintaining control and feeling important that it actually architects suboptimal security strategy that keeps it from getting a seat at the table. FOMOSEC's histrionics around desperately desiring a feeling of control make Infosec quite like someone that's ecstatically gripping a wheel, even though that wheel isn't attached to anything. And all that big wheel steering makes you feel like you're doing something, but you're actually staying stagnant. If you're staying stagnant, you're not actually promoting safety or stability. Shown as Dr. Nicole Forsgren and her colleagues' State of DevOps research, the so-called elite organizations who have the fastest deploy frequency and shortest lead time for changes, all of which is great, also actually exhibit the lowest change failure rates and the shortest time to restore service. Especially when you consider the typical ratio of security engineers to software engineers, it's basically impossible to scale any heavy security process anyway. What's interesting in that research as well is the organizations that have the most restrictions in place for changes and releases aren't actually the ones that are the most stable because they experience the highest change failure rates. The research shows that all these seemingly careful organizations actually see 46 to 60% of their deployed changes result in degraded service or ultimately require remediation. It's definitely not great. The point here is that the more hoops through which you have to jump, the more opportunities there are to fall on your face. There's a nasty remote code execution vulnerability in a library that's critical for one of your production systems. You want to patch it quickly, right? A heavy and inconvenient change management process is going to keep you from patching that quickly. It's going to make it harder to deploy a patch, which means your production systems will languish with their both security and stability at risk. But if your process is speedy, you can push out patches and fixes and other enhancements faster, allowing for continuous improvement of your system stability. A fortress of approvals and red tape and nebulous policy doesn't help security as much as ensuring that you can adapt your security program as your systems and environments evolve. If you can test and fix things quickly and easily, that will bolster your security far more than even the strictest policy. So how do we spot security theater's red flags, and is there a better way ahead instead? This brings us to Act 2, fisticuffs. There's a conflict born not only from how we should treat security failure, but also where accountability for security should rest. On one side, we have security theater. On the other, there stands security chaos engineering. We'll explore these tensions presently. The TLDR on security chaos engineering is that it seeks to leverage failures as a learning opportunity and a chance to build systems-level knowledge of systems-level dynamics and continuously improve systems resilience. I'm releasing a report on this topic with my co-author, Aaron Reinhardt, through O'Reilly. Should be out at the beginning of next month, so check that out if you want a deeper dive on it. Security theater, obviously, their vibe isn't nearly as chill. It will absolutely harsh your mellow. So the security team that acts in the security theater troop wants to avoid failure by any means necessary and punishes chosen humans involved in any incidents that occur. So let's go to scene 1, the duel. Teams who adopt security chaos engineering are kind of camus about things because they radically accept that failure is a natural part of complex systems as they continuously change. They don't expect to know all of the ways that things can fail, so they instead pursue and incentivize feedback loops as well as experimentation to uncover evidence. Teams who adopt security theater, though, are stubborn, lamenting that if only humans followed all of the Infosec laws perfectly, incidents wouldn't happen. Users are lazy or stupid or, the aforementioned bad apples, so they deserve to be ruled with an iron fist, despite the fact that policies are never going to globally apply given the nuance of just work being conducted. Security programs following security chaos engineering are designed to minimize the impact of incidents by making incident recovery as efficient and graceful as possible. Teams know that pointing fingers is absolutely useless, and that conducting experiments to power feedback loops is far more valuable. Security programs following security theater, however, use technology and policy to eliminate all possibility of failure and allow for easier blame when incidents occur. But no one can enumerate all possible sources of failure and keep them from happening with control, so what are they going to do? Teams pursuing security chaos engineering also want to unify accountability and responsibility by handing off acceptance of work to the engineering teams that are actually performing the work. The security team then operates as an advisor, sharing knowledge as widely as possible. Teams performing security theater, though, are thirsty for bottlenecks and silos. The security team is in charge of approving or denying changes and releases and really all of the things, despite being divorced from the actual work that's being conducted. Importantly, the bottleneck and the requirement for security approvals in itself is seen as improving security, even though those aren't actually security outcomes. Practitioners following security chaos engineering want to reward system-level improvement rather than rewarding the creation of roadblocks to change. They prioritize metrics like mean time to restore, which already exist on the engineering side, to try to ensure that Infosec is pragmatically aligning with organizational priorities. Security theater, though, as far as rewards, loves to say no and rewards saying no. It looks at innovation and says, that's too spooky for us, maybe try again later after Spooktober. Or the security team rewards alleged stability enhancements that actually slow down release cadence. As far as culture, security chaos engineering is all about a culture of curiosity. It's always down for a healthy retrospective and an open discussion of oofs, even big oofs. Teams feel super safe coming forward about security issues, knowing that they won't be ridiculed or blamed, and that problems can be solved collaboratively. Security theater's culture is the opposite. Because of its fear of change, it actually fosters a culture based off of fear of learning. Teams would rather keep security issues secret so they don't face retribution or disruption. It's all around kind of a bad vibe. Security teams with a security chaos engineering approach are all about providing a guiding light so that unfamiliar situations can be approached constructively. They welcome audience participation in challenging assumptions about existing security strategy because it's accepted that it will need to keep evolving as situations and environments and systems evolve. Security teams with a security theater approach, though, are a stickler for the rules and find the status quo very comforting. They would much rather copy-paste policies from the old world they know well to the new world that they fear, which is why you see things like container firewalls. Finally, as far as testing in security chaos engineering is designed to keep existing workflows as efficient as possible and integrate any new security tools or security testing as gracefully as possible. Feedback is provided quickly in a way that engineers can actually digest and understand so they can keep their foot on the gas. Testing in security theater, though, is designed to accomplish the impossible, perform manual reviews before any change or deploy is made. Security assessments come across like this arcane mystical art where a thumbs up or a thumbs down comes from on high, often late and with minimal context applied. So, do you want to thrive in the real world or in security theater's fantasy world? With security chaos engineering, teams accept reality, especially reality that security just isn't as important as things like making money, building a customer base, improving profitability, so forth. Security theater, teams are kind of method acting so hard that they start to buy into the fantasy land in which they're acting, and that security they start to believe is actually the top priority for which an elaborate song and dance is required. Those who adopt a security chaos engineering approach want to produce meaningful outcomes. They don't care about doing something for appearance's sake. As I elaborated upon in a recent post about YOLOsec and FOMOsec, security chaos engineering also doesn't encourage caring about feeling important or buying the latest security shiny just because everyone else is doing it. Most engineering teams already understand that bugs that can disrupt performance are inevitable. They try to continuously test and refine their systems to get the results they want. Security chaos engineering thinks similarly. Security bugs exist, misconfigurations are a fact of life, keys are accidentally going to be pasted into code, so it's quite silly to think that just because something passes a security check once, that everything is perfect. Joining the security theater, though, results in a dangerous self-fulfilling prophecy. If everyone is treated like a bad apple, they're more likely to hide and keep things secret, which ironically turns the innocents into the feared bad apples. They'll cover up mistakes and they'll be too scared or resentful to raise concerns, which completely dissolves your feedback loop. And it frankly erodes the security team's political capital too. Without that feedback loop, how can you be certain that your security program is actually working? This brings us to scene 2, judgment. Security chaos engineering welcomes objective judgment, but security theater would rather bribe the judges. Classic red flag of any security theater is that it's nearly impossible to directly tie cost to benefits. There's often a lot of hand-waving and purposely vague math involved. It's sometimes alarming to discover or rediscover how few Infosec professionals and leaders can articulate the return on investment of the dollars spent on their security programs. I think we can all understand that not being able to explain how dollars spent transform into organizational benefits is pretty problematic. Moving towards security chaos engineering as a result is a movement towards creating success criteria so you can track the efficacy of a security program in a quantifiable way. It may seem obvious, but you either want to prove that you've avoided a monetary loss, which to be fair is what's normally done on the Infosec side, or that you've helped facilitate some sort of monetary gain, definitely less common in Infosec. This calculation also needs to consider the effects the security program has on other parts of the organization, what's referred to in the economics literature as negative externalities. Drawing on an example in the physical security domain, one study by Blaylock and colleagues showed that road fatalities increased as a result of the additional screening measures that were put in place at airports after 9/11. This is because people decided to drive rather than experience the hassle of all of the security theater, security screening in airports. Security metrics are often, way too often, tone deaf to what the rest of the organization cares about. Honestly, no one cares about your phishing link sort of metrics, just like no one cares about lines of code written on the engineering side. It's a huge mistake not to include negative externalities in your measurement, because it keeps you from measuring security efficacy holistically. Really, any measurement of Infosec has to include and has to look at how other teams' measurements are looking and trending in order to track whether there's increased friction or increased inconvenience being engendered. An increase in code review coverage by the security program could be seen as a good thing. But if there's critical software delivery metrics like lead time or deploy frequency that are being hurt? It's ridiculous, obviously, to assume that any sort of change in engineering metrics is due to a change in the security program, right? The point is that these metrics open up an opportunity for investigation in order to investigate security's impact on all these other metrics and ensure there aren't negative consequences from the security program to what otherwise might appear to be security improvements. As is likely obvious, this is going to require collaboration between security and software engineering teams. The mutual benefits are ripe for the picking, as we'll explore in this next act. This brings us to Act 3, Redemption through Security Approval Patterns. The section will strive for security's redemption by exploring a pragmatic approach to security approvals. So obviously, security reviews for everything won't scale, and training every developer in security and all of the OWASP stuff also doesn't scale. There's no point in forcing these things also if there's a better way. Little's law shows that the number of items in a queue equals the rate of arrival, multiplied by the average time spent in the queue. We applied this to security reviews. We can see that if you reduce the queue of the security reviews, you'll reduce the time it actually takes to deploy code. How do you reduce the queue size? You separate out software delivery into high-impact, high-risk changes and low-impact, low-risk changes. The O'Reilly report that I mentioned, we show an example prioritization matrix of how to classify all these different organizational assets along those lines. The key is that you treat high-risk, high-impact, and low-risk, low-impact differently to prioritize your team's time and resources. Brings us to Scene 1, how to treat high-risk, high-impact changes. You only want to review the highest risk and highest impact changes among the security team, which requires obviously close relationship, which we'll talk about presently. The highest risk and highest impact releases or changes are those that create ripples enterprise-wide or even product-wide, rather than creating any sort of impacts at a feature level or even smaller level. By requiring software review only on those higher risk changes to systems or software, you're supporting organizational speed, and you're also more appropriately prioritizing the use of the security team's expertise and time. The security team can then focus more on strategic work rather than directing attention at high-volume, noisy changes that present lower potential impact to the organization. And who doesn't want to focus on more strategic work and higher value work rather than focusing on battling noise all the time, right? You also want to assign accountability for fostering awareness and facilitating stakeholder discussion to the product teams that are responsible for the release. They'll also be responsible for bringing the relevant stakeholders together for collaborative discussion around mitigation opportunities for those changes. Really importantly, business or engineering leaders have to be the ones to sign off on high-risk changes and agree that their teams are accountable for the risks. Let's say if an incident occurs. They should also give timelines on when mitigations can and will be fixed. You also need to time box your security reviews on these high-risk, high-impact changes and reduce their volumes to a level that allows for meaningful attention. You don't want to be spread thin everywhere. You also need to create a redundancy plan for urgent approvals that can't wait for a full security assessment. You need this just in case because that's just a reality of software delivery. You also want to develop transparent guidelines for what constitutes a high impact versus a low impact change. And also you want to encourage teams to reach out to the security team for clarification on specific changes as necessary. Again, you want that open, transparent communication channel. Then finally, it's really crucial to perform retrospectives on prior releases that resulted in tangible impacts, especially any changes that were deemed low impact and ended up having a high impact or a big incident, because all of that is a fantastic learning opportunity. And then any resulting observations from the retrospective should be shared across all of the relevant stakeholders internally. This brings us to Scene 2, low risk, low impact changes and how to treat them. The TLDR is that low risk and low impact changes are funneled through a transparent classification system and an automated exemption workflow. Incentivizing the right behavior is essential kind of across the board in life, right? But here, a low friction and standardized process for receiving exemptions incentivizes teams introducing the changes to appropriately treat the security issues of changes. If your process is cumbersome and heavy, you'll incentivize bypassing security processes. It's kind of like incentivizing people to sneak into a theater if the only option is to buy tickets by waiting in a super long line and you have to do it in person. You need to make the secure way the easy way, starting with funneling those low-risk changes into a separate workflow. And this workflow is specifically one that doesn't require security assessments and it doesn't require stakeholder-wide discussions. Really, it has to be as light touch as possible. You need to define also a straightforward classification system so teams can identify changes locally, such as low, standard, urgent, critical, and informational. Then you need to outline all the treatment steps necessary for each class of change. You also need to document all these lower impact changes for posterity, ideally leveraging pipeline automation to handle the exception process and create awareness about any exemptions. You also want, really importantly, to promote local approvals and peer reviews whenever possible for these low impact changes, leveraging the use of things like security champions, also something we discuss in the report. And importantly, keep an eye on the teams where they seem to keep flagging things or identifying things as low risk, but it actually ends up being a high impact, because there may need to be some sort of refinement to how you classify these changes, or even a revocation of their local approval authority. You also want to create a guide listing what types of changes can be performed locally without requiring security assessment. They can be things like pricing updates, changes to images like cat GIFs, or updated tooltip copy, because those are unlikely to ever be mission critical. So that we've reached the grand finale. Security theater prioritizes gatekeeping, preferring to punish humans for supposedly causing failures, even if it leads to a fear of learning that stifles continuous improvement. When security teams serve as an authoritarian external approval, bottlenecks are inevitable, and this friction in turn leads to longer deploy times and larger deployment sizes, both of which seriously jeopardize stability and thus security. Continuous improvement is our goal for systems performance, and it should be for system stability as well. Security chaos engineering is the path to get there. Plus, don't we always hear about how attackers are constantly evolving their methods and behaviors? So shouldn't our defenders and our defense continually evolve too? Security teams very, very beneficially can be freed from the burden of this heavy-handed control. They can instead become advisors who focus on more strategic work. Product and engineering teams can accept accountability for changes and for cleaning up any resulting impact of these changes, like an incident, making for a healthy security approval pattern for everyone. For that, I ask you to close the curtain on security theater and let speed and stability flow in concert. I always like to close with a quote that this time is by Chuck Palahniuk, who said, "People don't want their lives fixed. Nobody wants their problems solved, their dramas, their distractions, their stories resolved, their messes cleaned up. Because what would they have left? Just the big, scary unknown." As I said, feel free to check out the Security Chaos Engineering report that's out at the beginning of next month. And with that, thank you very much.